Okay, boys and girls, welcome back to Burmination here. We're talking about some good old-fashioned 5-2, and I wanted us to discover a little something before we start 5-2. So this would be kind of like a warm-up, get our brains thinking about the math that we have to do. So here's a step of problems that we need to apply to this 8 is greater than -2. And what we're going to do is just going to see what happens when we do some math to it. So if we add 2 to both sides, this is going to be 10 is greater than 0, which is a true statement. If we subtract 2, we're going to have 6 is greater than -4, still a true statement. If we multiply it by 2, 16 is greater than a -4, still a true statement. If we divide it by 2, we get 4 is greater than a -1, still a true statement. And if we add a -2, we're going to have a 6 is greater than a -4 again. Just like subtracting 2 and adding a -2 are the same thing. If we subtract a -2, it will be just like adding 2. So we're going to get to a 10 and a 0, still a true statement. Now when we multiply by a -2, this turns into a -16 and a 4. The sign must change for this to be true. So hopefully we'll notice a pattern here. The sign must change for it to be true. If we divide by a -2, we get ourselves, it was an 8 divided by -2, which is a -4, and a -2 divided by a -2 is a +1. So the sign again must change. The inequality sign must change in order to make this true. And the only thing that we notice here, folks, notice that we added, subtracted, multiplied, and divided by 2. We added, subtracted, multiplied, and divided by a -2. The only time that we needed to change our sign was when we multiplied or divided by a negative. So that's the rule that we're going to use. If you multiply or divide by a negative, we're going to have to flip the inequality around. So that's a big idea for our topic today. So big important question, how does multiplying and dividing inequalities differ from adding or subtracting? And all we're doing today is we're just, like yesterday we had the adding and subtraction equations or inequalities, we're now throwing in the multiplying and dividing. So let's get started. Example number 1. It says a -3/5 times d is greater than or equal to a -6. So to get d by itself, we have to undo the fact that we are multiplying by 3/5. So we can divide by 3/5, but that means we have to actually multiply by the reciprocal. So when we multiply both sides by the reciprocal, those cancel. Diagonally they reduce to being just a d on this side. And then we multiply over here by a same -5/3, and top times top, bottom times bottom, we get 30 over 3, a -30 over 3, and that's going to reduce to a -10. So d, and I have a -10 over here. Because we multiplied by a negative, my inequality switches sides. So d is less than or equal to a -10. I go over here, I have a closed circle at -10, and less than or equal to get shaded this direction to the left, because those are the numbers that are smaller than -10. Moving on. Same process here, we're trying to get the k by itself, just like an equal sign like we've done in the past. So to get rid of a times 12, we're going to divide by 12. And because we did not multiply or divide by a negative, the sign is going to stay the exact same. A is greater than or equal to a 5, because 60 divided by 12 is 5. So we have an open or closed circle at 5 and greater than or equal to shades to the right. Example number 3. Very similar to example number 1. Again, we're trying to get ourselves to have the x by itself, so we're going to have to multiply by the reciprocal, because when you divide by fractions, you end up having to multiply by the reciprocal. So we multiply by a -3 over 2, and those cancel over here. So we're left with x and because it was a negative, my sign switches. 6 times 3 is 18. 18 divided by 2 is a negative 9. So x is less than a negative 9. So we have an open circle, x is less than it, shades to the left. Now folks, that's pretty much all this lesson is. It's being able for us to redo solving equations, but instead of having the equation or the equal sign, we're going to use the inequality. Remember, you got to flip to make that work out. All right, here's your homework. Good